Welcome back to CIS 101. Last week, we talked a little bit about security. Second week that we talked about security. We talked a little bit about how identity theft is committed and some of the types of scams that identity thieves can perpetuate. We talked a little bit about the different types of hackers in the last 2 weeks, and even though specifically a hacker is technically a white hat person, who's performing duties in accordance with ethics and laws, and a cracker is a person with malicious intent. We tend to use the word hacker to encompass both white hat and black hat individuals. We talked a little bit about some of the various tools hackers can use and the types of attacks they may or may not launch against a computer or a network system. We talked a little bit about what a computer virus is, why they can be a threat to your security, and how a computing device can catch a virus and the symptoms it may display. We talked a little bit about the different categories of computer viruses and their behaviors. We talked a little bit about what malware is and some of the various types of malware, and more practically why you almost never want to open up a file attachment that's sent to you by somebody unless you absolutely know the person you're absolutely expecting the file. Talked a little bit about what spam is and some of the strategies you can use to combat it. We talked a little bit about cookies and their importance and the fact that they actually have a benign intention, although they can be used as a security threat. And we talked about social engineering techniques and explained some of the strategies that can be used to avoid falling prey to them. And I want to stress to you, social engineering happens a lot. Most of us, to get along with somebody, to make a good impression with somebody that you hope to work with or work for, or a good hire you want to bring on board. These, take them one step further, can all be considered social engineering tools. Today's chapter is Chapter 10, which is going to talk a little bit about programming. Okay, and most of you may be rolling your eyes saying programming, oh my God, doing math, solving math equations in a cubicle for 18 hours a day. It's not what I want to do. Okay, and the vast majority of programming is not that. Why you may want to pay attention to this, okay? The average programmer, not the manager, not the supervisor, the average programmer in the Chicago area is making just about $90,000 a year. And that's an individual. And again, bear in mind that the average family income in the U.S. pre-COVID-19 in 2019 was $60,000 a year. Okay, this starts looking really, really good. And it's very easy to break six figures if you're working in Silicon Valley, or if you move up into a supervisor or a managerial role just about any place else. Very, very common thing to do. What I'd really suggest you do is take a hard look at our CIS 101 Introduction to Programming class. Okay, see what it's like. See how see if it's something that you don't hate, because you may find that if you don't mind doing it, this is a really, really handy skill to have. Not just in the IT department, not just software programming. More and more companies, departments want to have somebody, not necessarily a full-blown dedicated programmer, but somebody with some programming skills in their department. Just because it can be a pain in the ass to actually coordinate for the assistance you need from the programming department when there's a lot of fairly simple things that can be done in-house in your department if you have somebody that knows what they're doing. Okay? What we're going to talk about first off, a little bit about the understanding programming, a little bit about what a life cycle of an information system is, and we're going to talk a little bit about the life cycle of a program and what those terms mean. Okay? And in doing that, we're going to describe the importance of programming to both software developers and users. And I apologize for this. And we're going to summarize the stages of the system development process life cycle, known as the SDLC. We're going to define programming and list the steps in the program development life cycle, the PDLC. We're going to describe how programmers construct a problem statement from a description of a task. We're going to talk about how programmers can use flow control design methodologies when they are developing algorithms. And I want to stress to you, we're just going to touch on this stuff. There's a very easy extra credit exercise that you can either do or not do. Not a problem either way. We're also going to discuss the categories of programming languages and the roles of the compiler, of the tools they use, like the compiler in the integrated development environment in coding. We're going to identify the role of debugging in program development, a lot like spell checking. We'll talk about that. And we're going to explain the importance of testing and documentation in program development. Nothing's done until you actually test and make sure that it works the way it should. Never mind that it should work. Okay. Just last week I was working on a computer, and basically I swapped out a traditional hard drive for a solid-state hard drive, which in theory should have simply speeded up everything it did. And the actual result was the computer's actually worse off than it was before, and I don't know why. But obviously I can't use it until I sort out just what the problem is. Okay, some of the considerations when you're looking at programming is that some tasks are complex and they require some creative thought. They may require a human touch. The human brain is actually a very, very complex computing device. We don't give it nearly the credit that we should. And it's one of the reasons, and because of its complexity and life circumstances being as complex as they are, that it's so much money is being thrown at, and relatively little progress is being made, incremental progress, in the whole concept of artificial intelligence, which we will talk about more in a later chapter. Some tasks are candidates for automation. This is where programming comes in. They're repetitive. They work with electronic information, and they follow a series of clear steps, much like a traffic light. It's either going to be red, it's going to be amber, or it's going to be green. And in fact, that's an example that's used frequently when you're talking about, programming concepts. Okay? I want to stress to you that a career in programming offers wonderful employment prospects, very, very low unemployment, very, very nice salaries, very strong salaries, and especially now, but even before this, telecommuting was often easy to arrange. Companies often found that if they were willing to broaden their job description to include telecommuting, they could broaden where people needed to be in order to get the work done. They would basically establish what needed to get done, and especially with the existing technology, the ability to do remote work is getting to be easier and easier. And this class is sort of an example of that, to a certain extent. Or when I talk about how computer programs exist for many tasks because they're repetitive, and in fact traffic control systems are a type of computer program. The lights are set to turn red, amber, and green, and use directional arrows at the various appropriate times, and it seems to be a very effective way of doing that. Programming is necessary when there is no existing software for the task. This is where programmers come in. They basically take a situation where there is no program existing, or one that doesn't seem to get the job done, and they turn around and they a person, or really a team of people, will do an analysis of what the current situation, what needs to be done, and then they'll move on it. And in order to do this, you have to have, even if you are not working in programming, you need to have a basic knowledge of programming and how it works. Okay? We define a system that programmers work with as a collection of pieces working to achieve a common goal. And an information system, which in programming is most of what we're talking about, is going to include data, it's going to include people, it's going to include procedures, it's going to include hardware, and it's going to include software. And it may very well include other elements that are not listed here. When we're talking about the life cycle for an information system, what we call the SDLC, or the System Development Life Cycle, we're talking about this first step. We want to identify exactly what the problem is. Make sure we're talking about the right one. It is our job, and there's an old joke about how people, organizations got all wrapped up and build up a department and just put a lot of money into their organization to kill alligators so it's safe to work in the swamp. And then somebody stopped and thought about it and said, well, wait a minute, what is our job actually? And their job was to, drain the swamp. Killing the alligators was wholly incidental to it. Then, once you identify the actual problem, not the possible other problems of it, you're going to do an analysis of the situation. Okay? Once you've done an analysis of the situation, of the proper problem, you're then going to design what you think your solution is going to look like. And then after you design your solution, Then, and only then, you're actually going to start developing, the programming and the code for it, which includes, and once you've done that, you're going to test what you've done, and and as it works and passes muster, you're going to install it. Then you're going to maintain and evaluate it. Okay. Now, within that, we also have what we call the program development lifecycle, which is specifically within the software development lifecycle. This is the program itself, and this breaks down into 5 steps, where you're going to describe the problem, exactly what the problem is. Then you're going to make a plan. This is where you're going to basically graph out. You're not doing math yet, but you're going to graph out within the SDLC specifically what the algorithm should look like. Then you're going to actually sit down and start writing the code one step or block at a time. Then you're basically, just like a document, you're going to do spell checking, except instead of spell checking and grammar checking, you're going to debug it. And then basically after that, you're going to then test what you've got, document what you've got, see if you need to go back and do some more debugging, or then you're going to slide back into the SDLC and you're going to look at fielding your solution. Okay? The problem statement, okay, is necessary to solve a problem. You can't really solve a problem until you agree on what the problem is. And a big part of this is interacting with the users, because what management says may be the problem may not actually be the problem. The users are the ones who are going to know what the problem is. I don't know how many times I've had a problem with a web interface, and I, basically talk to the manager and stuff. Oh, just go do this, go do that. And it's like, they never really have used their web interface, or they would know that you can't do what they're saying to go do. Okay? Programmers can handle bad inputs through error handling and then try to solve it. And the problem statement includes the testing plan once you identify the problems, to how you're going to test them to see if they're gone. And bear in mind that this does not cover every possible input, but patterns of inputs. Okay? Then you're going to, and we'll get more into this in a little bit, you're going to develop a detailed algorithm. Okay? Generally, they're going to be a little bit, again, we're not talking math, we're talking about symbols like you see here. And a big part of CIS101 is basically just working on the, the SDLC and the PLDC, and just like on a map, learning what the symbols and the colors and the lines on a map mean. You do the same thing with an algorithm. You learn what each of these algorithms mean, how they work together, and basically, how to provide a visual representation of what you're planning to do. Okay? Then you're going to work on flow control, just how the various steps of the program or blocks of the program should work with each other, your lists of choices, your decision points, and how those decision points are going, where they're going to be and how they're going to look. Are they a binary decision? And when we say they're a binary decision, they were saying, are they yes? Are they no? Like, are you going to bed tonight? Yes or no? Not about when, just yes or no. A lot of times I will have to get with my kids about something, and I'll ask them a simple yes or no question, and they'll give me no, yes or no. That's all I need to hear. And then there'll be other points in a program, okay, where you're going to have loops. And again, the classic example of this is like traffic lights. Is the light, depending as you're approaching a traffic light, is it red? Is it amber? Is it green? Depending on what it is, it's going to dictate what you're going to do. And if you're stopped at a red light, again, as long as the light is red, that's going to dictate some things you do. When it turns green, it's going to dictate some things you do. And in some countries, it won't be just red-green. It'll be red-amber-green, with the amber, meaning get ready that it's going to turn green, just kind of like a heads up. Okay. We're also going to look at design methodology, top-down design. This is something that you blow into a little bit in CIS121, which is basically the concept of breaking a problem down into a series of high-level tasks, and then breaking down those high-level tasks and subtasks. And it can be as simple as, when I clean my house on the weekends, I don't just say, oh, I need to clean the house. It's like, okay, how am I going to clean the house? And generally what I'll do is I'll put on a John Wayne movie or any other good movie. And then on the commercial breaks, I'll start with my daughter's room and I'll clean it up and grab her sheets to go wash them. and then the next commercial break I'll go do the hallway, and then the next commercial break I'll go do my son's room, and then maybe, basically each commercial break, and I may need 2 or 3 commercial breaks, I will do a various part of the house and work my way from top to bottom until it's clean. And then, I have to go outside and, do my poop patrol and take out the garbage. And then, depending on the season, do I have leaves that need to be raked? Do the cars need to be washed? Do I need to shovel the snow? What tasks are there that need to be done? And this is all part of your top-down design. Okay? And how top-down design is used in programming is you have to get you determine, okay, we need input. How is that input? What kinds of input can we expect? Then we need to process the data. What kind of data can we expect to process? And then we're going to output the results. Okay, what kind of output are we expected to provide? What is acceptable? What is not acceptable? And here is an example of a design methodology using object-oriented analysis. Okay, where you have your data information and you basically determine what classes of information you're looking at, and then you then determine what methods, or really what actions, because this is object-oriented, you're going to be inputting or providing, and then what output you're going to be providing. Okay, and again, CIS121 does not turn you into an expert on this, but it gives you an acquaintance for this and how programming works. And I want to stress to you again that it is IAI, Illinois Articulation Initiative, credentialed, so that our CIS 121 class will transfer to any public 4-year school in Illinois and really around the country, because it's a nice credential. Everybody in Illinois uses the same building blocks, the same structure for their IAI. They all have to contain the same things, which is a little cumbersome to get used to, but it means those classes are good anywhere. Anybody from any college can be expected to learn the same thing someone's learning in any other college. Okay, and here's another example of some of how a flow chart might look. Okay, that you're working with, and I want to stress to you that this is something that you guys are used to working with all the time. You do it on a regular basis. All right. I do this, my kids do this like every day at home. Okay, just can't, it's routine. See if I can get this to come up. And didn't work out nearly as well as I'd like to. But anyhow, if you look at this flow chart, it clearly shows you, starting here, is it working? You have your 2 binary decisions. And most of this is a binary flow chart. Yes or no. Did you mess with it? Yes or no. Don't, does anyone, if you broke it, does anybody else know? Yes or no. And can you blame somebody else? Can you hide it? Can you look the other way? Yes or no, which result in no problem. And if there is a problem, then you're an idiot. You're toast. Okay. This gets us into the life cycle of program coding. And again, when we talk about coding, we're talking about, this is a part of programming that most people think of programming. When we talk about the actual coding, is what people tend to think programmers do all day long. And coding is only something that a team of people will get into once they pretty much determine, okay, what we need to do and what it needs to look like and what we want it to accomplish. And programmers will move from algorithm to code as a team, not by individuals, by identifying key pieces of information, by identifying the flow of each step, and converting the algorithm into a specific programming language that the team has agreed to work on beforehand. You don't just get to this point and say, okay, now what language are we going to work on? Programming languages are basically a language that the computer understands. It's a code, like a language, that the CPU looks at to tell what needs to happen. Languages can use special words and strict rules, and they allow for the programmer to have control of the CPU without knowing the hardware details, because they know that by using the language and providing these instructions in the language, certain things are going to happen, and they can expect them. Just like when it's very hard for an individual to give instructions to another person unless they speak the same language. If they do speak the same language and they have the same cultural understandings, then they are not going to have any problem about what has to happen. Okay, and bear in mind, and this is not the problem of the programmer, the code, once it's written, is going to be converted into ones and zeros. It can be those binary ones and zeros, which is all the CPU really truly understands. The compiler is going to create an executable program for the CPU to work with, okay? And some languages may use an interpreter instead of a compiler, but the result is the same. And it's basically just a translation. You'll be writing in a language, and a compiler or an interpreter is going to take what you've written after it's been debugged and checked, and it's going to compile or interpret it into zeros and ones for the CPU to process. Okay? And some of the tools that can be used for this include what we call integrated development environments, okay, which is basically software tools that programmers write to basically write and test their programs to see that they're going to work. And this includes the concepts of debugging, which is like grammar and spell checking, where you use programs. So there are actually tools out there that will look at the code you've written and say, hey, this doesn't look quite right, or hey, this, it's like grammar or spell checker. It looks at what you've written and it tells you, does it pass the smell test, yes or no. Now, testing plan is what programmers use to help them know when a program has solved a problem, and they can run a test and it seems to work. And a classic example of this would be during the 2020 election. Some of the software programs that were purchased by some of the some 46 counties, say in Wisconsin apparently, or Michigan, were inadvertently converting votes from one party to the other, and apparently on a rather large scale. Okay? Obviously, the program wasn't really bug-free when they sold it to the state, and I'm sure there's going to be some discussions about that. But the point is, the program was sold, and in fact, it wasn't working the way they wanted it to work. There were some oopsies there. Okay, programmers are also going to want to look at their compilation errors, and they're going to want to look at the logical errors. Okay, the program runs, but it executes incorrectly. And that might be a good example of what the balloting software problems they're having. The program ran and says, but it was not attributing the votes to the correct candidate. Oops, can't really have that. Okay. Also, within the life cycle of a program, we have what we call testing and documentation. There'll be internal testing, okay, within the group. There'll be external testing, possibly as part of a beta, which is the next thing we're going to talk about, where you deploy it to a slightly larger, more real-world scale to see if any problems develop, and then if problems come up, then you can expect problems to come up because you can't think of everything. Then you're going to solve them after the beta testing. Then you're going to finish the project, at which point you're going to release it to the manufacturers for sale and distribution. You're going to document everything you've done, okay, and make it generally available. And then basically, as part of the maintenance, as problems come up, you're going to go right back into the SDLC, and you're going to identify the problem. And the maintenance never really seems to stop. Okay. In case in point, Microsoft just recently put out a blurb that effective in 2021, they're going to stop support of Windows 7. Okay, which has been around a long time, but they can't support it forever, and there's always going to be things that could be made better. Certain problems are going to pop up. Sometimes when you solve a problem, another problem pops up. And the solution to that is to, at some point, you move on to a new product, and you have to draw a line where, at this point, we're not going to support this product any longer. Okay? Now, we talked a little bit about the general concepts of programming. Now we're going to talk about the programming languages that you can use. Okay? And in doing that, we're going to discuss some of the driving factors behind the popularity of various programming languages. We're going to summarize the considerations in identifying an appropriate programming language for a specific setting. We're going to compare and contrast modern programming languages, and we're going to talk about some of the key principles in the development of future programming languages. Okay? And there's a lot of languages that when you talk about programming, it's not just simply a matter of saying, I need a programmer. You really need to figure out what languages are in demand, and that can be a little bit tough. It's a little bit like on the network administration side of it. There's more than one network operating system. There's the Windows operating system, there's network operating system, there's a Linux operating system, and there's various distribution flavors. There's the Apple operating system. They're all going to be different. Same thing is true on the programming side. There are different languages, and just like cars and trucks, they all have strengths and weaknesses. It doesn't hurt you if you go onto one of the job boards and just run a search for programming jobs and just look what programming jobs that they're looking for. Certain languages are going to dominate in specific industries, and most introductory programming courses will include, just like our CIS101 does, concepts of design, concepts of algorithm development, concepts of debugging techniques, and concepts of project management. And in fact, and all of these you can go into in tremendous detail. And in fact, you can actually pick up a degree in program management, project management in various industries, as well as in programming. And there's just a huge amount that can go into. There are actually credential certifications you can get as a program or project manager that companies like IBM specifically require for any of their program managers to have. Things you want to think about when you're sitting down deciding what kind of programming language you're going to use is how much space is available, okay? How much speed is required, what kind of organizational resources are available, and the type of target application, okay? If it's a visual programming language, okay, examples can be like Scratch or App Inventor, okay, and there's a bunch of them out there. Some of the classics that everybody should learn and become familiar with, in fact, we teach here at Triton College as part of IAI, are the C, C++ family, okay? You also have Java, you have Objective-C, you have Visual Basic, and they all have features and the typical and examples of the typical setting you can expect to see those in. And then you have web technologies, okay, such as AJAX, HTML, the current standard is 5, VBScript, XML, which basically enables users to define their own tags, and companies that are acquiring other companies really like because it facilitates picking up information from different kinds of databases rather than having to rewrite a database entirely before you can pull out the information. Okay, and JSON. Okay, now, while there's a lot to know about programming languages, I would really like to stress that we know that there will be changes in the future, but it's not always easy to predict where they're going to go. 10 years ago, everybody thought that Windows C# was going to be the future, and in fact, Windows C# is deployed, but you don't see it, taking off all that quickly. Then, in various, there was a period of time when Ruby on Rails was going to be the next great wave in programming. Everything was going to be done in Ruby on Rails, and that, in fact, has not come to pass. There was a time when BASIC was considered to be passé, and it was phasing out. And to a certain extent, and that's the first language I learned, BASIC has been superseded by it. But Visual Basic is still pretty popular and still used in quite a few places. So it can be surprising sometimes the strength, the staying power of a particular programming language if there's a demand for it. Okay, what we do know is that it's not going to be easy to predict exactly what is going to be popular in the future. Okay, we do see that there's probably going to be an increase in the use of what we call visual programming languages, but because of the different settings that programming languages are going to be needed for, we will almost certainly always need a variety. And realistically, while you can pick up a new programming language very quickly, the reality of it is that, just like on the networking side, you can't know everything. On the programming side, you can't know every language without some time to pick up what you do need to know. Okay, we have talked a little bit about the importance of programming to both software developers and users. We've talked a little bit about the stages of the system development life cycle. We talked a little bit about programming and the steps in the program development life cycle, the PLDC, which is distinct from and is a component of the SDLC, the system development life cycle. We've talked a little bit about how programmers construct a problem statement from a description of a task, and, just a refresher on that. If I tell my kids, and this is actually a good example of how not to do it, but it's common, to put on their shoes and socks, which I do most days for school. Don't know why I have to tell them this, but I do. Okay, I'm actually, and they're smart enough because, and this is because the human brain is actually a really, really good computer machine. They know that I don't mean put on your shoes, put on your socks. They know I really mean put on your socks, then put on your shoes. Okay, and then we've talked a little bit about programmers, how they use flow control design methodologies, okay, like the waterfall method, when developing their algorithms. We've discussed some of the driving factors behind the popularity of some of the various programming languages, and it really comes down to demand and can they do what they're supposed to do. We've talked about some of the considerations in identifying an appropriate programming language for a specific setting. What does it need to do? What are the constraints it has to work within? Okay, what is the availability of talent? Doesn't matter. You may have the perfect language for a particular program or a project, but if you can't find anybody who can use that language, then you have a problem. So you need to think, okay, what language do we want to use, and are there people available who, that we can put on this project who know that language already? You don't want to hire people who say, oh, I can learn that, not a problem. It's like, well, we'll hold on here just a minute. Okay, and you want to compare and contrast modern programming languages. Okay, there are a number of them, and some of the key principles about the future of programming language development. We know that we know that it will probably surprise us. We know that there will be some it will be driven by demand, and that there will be changes, but we don't always know what they're going to be, and you have to be prepared to be flexible. Okay, in announcements, I've gone ahead and put out a Hello World extra credit opportunity for everybody. I strongly urge you to, do it. Basically, just type it out, not what's on the slide, but what's in the example that I'll put out in announcements, okay? And then submit it in assignment 14 for this week's extra credit. Okay. For this week, nutshell, read through Chapter 10, look at the review questions at the end of Chapter 10, look at the Hello World programming exercise, turn it in for extra credit. And again, I want to stress to you that we've seriously considered, because our CIS101 transfers everywhere, dip your toe in the water here. You may find that, this is not something that, this is my passion, I want to do it. Real world. If you find that you can do this, if you find you don't mind doing this, this is a job with healthy job demand and healthy salaries that you may want to take it upon yourself. A little bit of skill is a nice to have thing. If you find that this is something you don't mind doing, okay, the pay and the work conditions are really excellent. Okay, should have done PowerPoint chapters 1 and 2 last week. We want to do PowerPoint chapters 3 and 4 this week, and in either, depending on the edition of your book, either 3 or 4 talks about inserting audio and video files into your PowerPoint. The takeaway from that is it's nice to know that you can do it, but the reality is when you do it, audio and video in particular can make huge files, and they can really swell the size of your file size and make it impossible for our Blackboard learning management system to accept those files. So don't actually insert any audio and video, because that can just make it impossible to do anything with the file. So we're going to finish up 1 and 2 if you haven't already. 3 and 4 is what we're working on this week. Next week we're working on our PowerPoint quiz, okay? And in a little bit more than a month, okay, and that includes almost a week off for Thanksgiving, we're going to have our final exam. So you want to be thinking about that. Any questions?